I'd be happy to separate you. Triangle bisectors. First thing before we start talking about bisectors and things inside of a triangle, I want to talk about a perpendicular bisector. And some things that happen with a perpendicular bisector. Okay? Let's see. Call this point A, and call this point B. Now, a perpendicular bisector. What do you think happens in a perpendicular bisector? Perpendicular means intersect to form a 90-degree angle. What does bisector mean? Cut in what? Half? Okay. So if I was to describe what a perpendicular bisector was, let's define it. Let's see. It's a line or segment that cuts another segment in half and is also what? Perpendicular, or also we'll say, so we don't say that word again, we'll say creates a 90-degree angle with the segment it bisects. Makes enough sense, doesn't it? So now I'll draw one. First of all, let's cut this in half, and I was convenient and nice enough that I made this easy number to cut in half, and then from there I need to make what, 90-degree angle. So that is an example of a perpendicular bisector. Another thing we're going to talk about is the perpendicular bisector theorem. What it basically says any point on a perpendicular bisector, what does that upside down T mean? Right. Is equidistant to the endpoints of the segment it is bisecting. And what do you think that means? When we start talking about equidistance and things like that, we start talking about things we're probably going to apply to problems, huh? That we're going to have to know that that happens. What do you think I mean? It says any point on a what? Perpendicular bisector. So what is our perpendicular bisector? We'll call this L. L is our perpendicular bisector, is it not? Yes. So everyone look up here. And I'm saying it's equidistant. Any point on it is equidistant from the endpoints. So that means if I drew a point up here and I called it C, what does that mean? That should be what? Equidistant to what? Each endpoint. And let's zoom in and see if that turns out to be true. What about right here? So that would be 1.5, and then 2 marks, then a little bit past that, right? Okay, let's see what we get here. Exactly the same. So if I drew another point, let's call it D. What should it be? Equidistant to the what? Endpoints. About right here, 1.5, and then 2 marks. Or no, I guess it must have been 1.5. And, yeah, there we go. There's 1/4, wasn't it? Okay. So that turns out to be true, doesn't it? And if you think about the concept, does that not make sense? This, we know that right here it's exactly in the middle, right? And then it goes straight up and down, doesn't it? So it doesn't lean any closer to this point or lean any closer to what? That point. Hence, it stays in the middle. Now, the thing that's also true, let's say, for instance, all I told you was this. Everyone just look up here. All I told you was that. All I told you is that this distance is equal to that distance, and this is a what? Bisector. It cuts this in half. What do you think I can say? If this distance is equal and this distance is equal, what do you think this line here has to be? A perpendicular what? Bisector. So underneath the perpendicular bisector theorem, we could say, and vice versa, right? And if you look in the book, what is underneath the perpendicular bisector theorem? Somebody tell me. Turn to the section. Section 6.1. What does it also tell you? What's underneath the perpendicular bisector theorem? No one knows, huh? Those of you wondering, those books are the orange things under your desk. In case you've never seen that before.
On
Yeah.
this one, it has like the plate on it, angle sum, and
But what does it say underneath the perpendicular bisector theorem? What's right underneath it? Is there another theorem called it?
there's another theorem.
Oh, I mislabeled this. Let's go to section 5.1. I got you guys mixed up with math finance. Math finance, we're on 6.1 today, and this we're on 5.1. So, and what it says is the converse of the perpendicular bisector theorem. So, this is what the vice versa basically means, isn't it? That we're saying that if it's a perpendicular bisector, that it's equidistant. Well, then we're saying if all the points are equidistant, then it must be on a what? Perpendicular bisector. Okay? Now, remember, we were just talking about, in general, just a perpendicular bisector. Okay? What we're going to do now is we're going to apply all these into a triangle. And these are very difficult to draw to look correctly. So I ask right now that you probably either draw this on your own later, or we just or you just look it up here and pay attention. First of all, concurrent lines. Write this down. That is when three or more lines intersect at the same point. And that is called the point of concurrency. What we're going to do in the next couple sections is we're going to talk about some special concurrent lines. The first one we're going to talk about is the circumcenter. The circumcenter is where the perpendicular bisectors of the sides of a triangle meet. Now, if you look at these, is it not pretty obvious that these are in the middle for each one? Would you guys agree? Now, and they're also what? Perpendicular. The reason I drew them like this is you'll see a lot of times in the book, this is how you'll see them. But if you were to extend these lines, they'd look like this, wouldn't they? Everybody see that? Okay. But in the book, you'll see them drawn like this. Okay? Where they don't extend them anymore. And it's important that you see them like that. And it's confusing enough to look at this and see what you're getting before you, if I extended these lines all out. Okay? So that's why I just kind of pre-drew them, and I thought that'd be easier to explain this. Because it's a pretty simple concept. Basically, when you have perpendicular bisectors, they'll always meet at the same point of each side of a triangle. Now, what happens that's significant is this. We are going to look at this side right here. How would you describe the segment I'm drawing? I guess since I'm drawing it in pencil in a different color, I can go ahead and, I don't have to dot it. Starting to look a little jumbled, isn't it? I want you guys to look at those segments. What do you think they look like? Huh? How would you describe that segment? That's a segment going from what? The circumcenter to the what? Each what? Vertex, right? Look at those segments. Is there anything that, I know I say not to go by how things look, but just, if you're just looking, what do you think you can say about those? I don't know about you, but I look at this one. Isn't it the same length as this one? Doesn't it have to be? Why does it have to be?
Because the perpendicular bisector theory.
Exactly. Those two have got to be congruent, right? Now, turn it around and just look at this. that comes from the perpendicular bisector, doesn't it? To the endpoint? This has to be what? Congruent to that, does it not? Now turn it around this way. Same thing, huh? So what do you think happens with the circumcenter? What do you think, what else could I say about the circumcenter here? It is what? Equidistant from each what? Vertex of the what? Triangle. So when I draw you a picture and I say this point, if we gave it a name, let's say A is a circumcenter, what all do I tell you is true? If I say that's the circumcenter, I know that these all have to be what? Perpendicular what? Bisectors. So I know it cuts this side in half, this side in half, and this side in half, these side in half. And then I also know that the distance from the circumcenter to each vertex is always what? The same. So by just saying the simple sentence, that is a circumcenter, I tell you all of that happened. Hence why we're probably teaching a section over it. Would you agree? So that's what you're going to be, the information that's going to be given to you for this section, you're going to be expected to apply that. They might give you this distance and then say that's the circumcenter. Well, that whatever that distance is, that one's the same as that one, isn't it? See what I mean? Those are the type of problems you're going to get. So we have circumcenter. The other one we have, it's called the incenter. Okay? The incenter is where the angle bisectors meet. So what am I saying here? I'm saying that each of these red lines I drew are what? Angle bisectors. So I'm saying this is congruent to what? That. This is congruent to that. This is congruent to that. Would you guys agree? Now, let me tell you something interesting about an angle bisector. So let's go down here, before we go back to this, let's go down here and talk about as simple an angle bisector. Now, let's move this like this. Something interesting happens with angle bisectors too. Let's see how big's our angle here? Hits that 5, so 225 minus 180, that's 70, 20, 45? Is that right? 45. So that means we need to go 10, 20, so about right there. Any point on an angle bisector is always equidistant to each side of the angle it bisects. Now, before we talk about this, I need to remind you guys, and we have talked about this before. Don't write this down. Okay? How do I find the distance from a point to a line? This always confuses people. But when I put a realistic spin on it, they do a little better with it. How about what did I just draw? A nice, pretty airplane, didn't I? A lot of you have probably been in an airplane before in your life. Correct? How do they measure altitude? Do they measure it like this? Would you guys say that's how they measure their altitude? If you were to describe to me how they measure the altitude when you're flying, or how high something is, how do they measure it? What would be the words you'd use to describe it to me? Straight what? Straight down, up and down, right? Would you guys agree? That's how they measure the altitude of that plane. Do you guys know what straight down means in geometry? Perpendicular. I mean, wouldn't it make a right angle? Doesn't that make sense? That's what straight down is. So anytime you're measuring a point to a line, you always measure it along a what? Right what? Angle. So back to here. If this is a perpendicular if this is an angle bisector, then that perpendicular distance has to equal what? That perpendicular distance. These two have to be what? Congruent, no matter where we are on this bisector. And I didn't draw that perfectly, so I mean, I'm sure I'm a little off, but you see the point I'm making? Anywhere along this bisector, this distance is going to be the same as this distance. Okay? Does everybody understand that? Now, back to applying this to the perpendicular bisectors of the vertexes of a triangle. So I'm going to take the distance from here to here along a right angle, and then the distance from here to here along a right angle. What do you think I can say? That has to be congruent to that, doesn't it? Because if you look at just that, isn't that the same thing we just did? Here's the angle bisector. This distance is equal to what? That distance. And it looks a little off because I didn't draw that very well, did I? Isn't it amazing how just being a little bit off can really change the perspective? Okay. Now, let's move over to this one. Wouldn't that distance have to be the same as that distance? Because this is an angle bisector. So all the way around, when you just think of one, right? Angle bisector, these distances are equal. Angle bisector, these distances are equal. An angle bisector, these distances are equal. So, when I say that this is an incenter, what are all the things I tell you are true? I tell you that what? These are all angle bisectors, so that cuts them in half. And I say that the perpendicular distance is what? Equal. So two words, incenter and circumcenter, tell you a lot about a triangle, don't they, once they're drawn? All right. Let's get workbooks out. We'll do a couple problems. Not many. So I do want to give you some time, but this is a section that if you understand it, you won't have any problems with it at all. But if we try to rush through it, you will. This is one where we're just, they tell you just this. They don't tell you whether it's, what have they left out here? They have told you that this distance is equal to this distance. They have told you that this line is perpendicular. So if the distance from any point is equidistant to the endpoints, what do we know it? This has to be called a what? Perpendicular what? Meaning that's congruent to what? That. So how am I going to find x?
5x minus 17 is equal to 3x.
And they asked me to find FG, and that's this distance from here to here, correct? If I have x, can I find that distance? So I'm going to subtract 3x from both sides. I'm also going to add 17 to both sides. And as you can see, I get 0 there, I get 0 there, so I'm left with 2x is equal to what? 18? Divide by 2. X is equal to 9. Now, don't go through all this work and then not, what does the question want? F to G, right? Well, F to G is 5 times whatever x is, which is 9 minus what? 17. 5 times 9 is 45 minus 17. Pretty sure that's 28. Okay, I'll zoom out and freeze this so if you need to write it down, but I want to get on to the next ones. As you see, we'll have some others, but then you're going to get one that's what? About perpendicular bisectors. What do I know about perpendicular bisectors? They're what? Equidistant here and here, correct? So, as a result, what are these two? If these are equidistant, then what does that have to be? They have to be congruent, don't they? This has to be an angle bisector if they're equidistant to the sides. So here it'd be what? 4x minus 1 is equal to what? 2x plus 5. I'm going to subtract 2x, but I'm also going to add 1. I'm left with 2x is equal to 6. X is equal to 3. They asked for MYW. So that's 2 times whatever x is, which is 3 plus 5. 2 times 3 is 6 plus 5. The answer is what? 11. Now, if you look at number 7, 8, and 9. 7, 8, and 9, they tell us that P is the what? Circumcenter. Now, I've been teaching this for about 15 years now. I've been teaching math for almost 20. I know what circumcenter is. When I read this, are you guys, is this just going to pop into your head probably? First couple times you might have to look back in the book and see, remember which one is the circumcenter. That's part of doing this homework and helping prepare you for the test. The circumcenter, what does it say in the book? It's where the, someone look that up for me. What is circumcenter? Look for this word in the section. So it's where the what? Perpendicular bisectors meet. So when I go to my picture, here's P right here. This is where all the perpendicular bisectors meet. So what does that mean this side does? Gets cut in what? What does this do? Cut this side in what? What does this side do? Cut it in half. Well, what does it also tell us about the distance from that to the vertex? They're all what? So that's congruent to that, which is congruent to that, which is congruent to that. So by just saying the simple words P is the what? Circumcenter, it told us all of that. That's what we're trying to get, that's what we're trying to teach you in this section. And then apply that. The funny thing is I've probably answered every question that they're getting ready to ask me just by marking that. I bet you money I have. Well, they want to see what list segments that are congruent to each segment. So what's congruent to BR? BR. What's congruent to BR? I answered it, didn't I? Or I at least marked it, correct? To where I just have to look over here. CS is congruent to what? Well, let's see. C to S. What would it be congruent to? And then BP, B to P, would be congruent to what? B to P. Well, this one has how many marks?
4.
So what's it the same as?
PC, PN.
P to C, which is also congruent to what? All I had to do is look at the marks, didn't I? So in a way, I marked everything already, didn't I? By just, this is a circumcenter. If you know all that, then you should be able to answer every one of those questions. Correct? Now, on 10 through 12, what do they say? They say point A is the what? Okay, so let's go over here and say everything that says is true. They say this is the end center. Well, they made a mistake. They should make this, that doesn't have to be 90 degrees just because that's the end center. So the book made a mistake. They should mark this for you. But being the end center, it's saying that this is congruent to what? That. This angle is congruent to this angle because that means all of these have to be what? Angle what? Bisectors. And that the distance, perpendicular distance to each side is all the same, is it not? I bet you money that you've kind of said how to do every one of these. Would you agree? They want to know, find each measure, ARU. A, where's A at? Okay, A to R to U. What's it congruent to? 40 degrees. So that makes this one what? Right? They want to know AU. What's the difference here? What am I saying when I say AU and I don't put anything above it? I'm asking for what?
The segment?
Nope.
No.
When I say this, I'm talking about segment AU. When I don't put a segment above it, what am I asking for? The distance from A to U. Okay, those are one of those things you guys got to know. What is the distance from A to U? Well, they want to know the distance from A to U. Well, the distance from A to T is 20. Does this have to be the same as it? So that makes the distance from this one what? Then they want to know the measure of QPK, angle QPK. Q to P to K. So they want to know this one. What do I know about these two angles? They are congruent, correct? If I find X, can I find this angle? How do I find X? 3x plus 2 would have to equal what? (51) is equal to X. 51. 11. I saw that there and saw 4. See, even doing this as many years as I have, if you don't watch how you write things, you're too messy, you'll mess yourself up. I mean, there's no doubt. See, I read that as a 4. I saw that 42. Anyway, 11. But is that what they asked for? No. They asked for this angle, which is 3 times whatever X is, which is 11 plus 2. 3 times 11 is what?
33.
Plus 2 would be? So as you can see, once you understand what this is and what this is, it's a matter of just what? Marking it, and you got it. I know this was a wordy day, but I will, to be honest with you, it's one of those days that if you get it, this is super easy. I mean, think about, all I had to do is look at this and know if that's 20, that's 20. I mean, how hard was that? You guys have 5 minutes. I'll expect you to work on this for those 5 minutes until the bell rings or no one leaves at the first chime. Hold on. And this is section 5.1. There's your assignment down there. I will zoom out a little. Does everybody get the first one, or do you want me to zoom out so you can write down the first one? I did record this.